If we turn our attention to studying linear differential equations, then we want to look at the simplest of all. And the simplest would be the first order. So, how does a linear first order differential equation look like? Well, it's going to have a first order derivative. So, let's say dy over dx. And then it may have a term involving the dependent variable y, but that might come with a coefficient which is a function of x. So there is a term with dy over dx, and then there is a term with y, and then there could be a term that does not involve either the derivative or the dependent variable, but it might be just some function of x. So let's say q of x. Now notice there could have been a coefficient which is a function of x for dy over dx. In that case, we could divide throughout or both sides of the equation by that and still say that the derivative has a coefficient 1. Now this form is called the standard form of a linear first order differential equation. And we want to find a way to solve this particular equation. Notice that this has two terms, a derivative term and then another term that does not have derivative but has dependent variable. Now, if you think back to the product rule of our differentiation, then whenever you have to differentiate a product, you get two terms. So our goal is to multiply both sides of this equation by a suitable function, which would turn the left side into the derivative of a product. So let's say that nice function is called I of x. So if I multiply both sides by I of x, then this is what I get. I of x dy over dx plus I of x p of x y equal to I of x q of x. And we are multiplying by I of x so that now the left side looks like the derivative of a product. So let me write down product rule first. If I have to differentiate a product of two functions, then it's f prime g plus f g prime. And now I want to see this dy over dx as f prime, which means f is same as y and this g is same as I. So what I want to see the left side as derivative of f was y times I of x. G was I of x. And that I want to say is I of x q of x. So this is f prime and this is g. And also notice that f is y. So g prime is this. So the derivative of I, g was I. So g prime is I of x p of x. So I want to see the derivative of I is I of x p of x. So now I want to divide both sides by I of x. And notice if I have I prime x over I of x is equal to p of x. Now if I integrate both sides, then this simply becomes natural log of I of x. And this is the integral of p of x. And that means I can solve for I of x. I of x is simply e to the power of integral of p of x dx. Now this function is called the integrating factor. So this is called the integrating factor. E to the power integral p dx. Now let's look at an example. So say